Let's work a physics problem. This is from Chapter 18, OpenStax College Physics. This is question number 25. So the question says there is a positive and a negative charge of 5 microcoulombs and negative 3 microcoulombs, and they are 0.25 meters apart. And the question is, where could you place a third charge so that the net force is equal to 0? There's a mosquito. Look at that. Okay. Don't worry about the mosquito. Okay. So I drew a little picture here and I have a diagram, but I want to draw another picture because I want to just sketch out. I put the positive charge at the origin, the negative charge over there, but let's think about this for a second. So here's my positive charge, here's my negative charge. I need to calculate the location of this third charge so that the net force is 0. So I have a force from the positive charge and a force from the negative charge. Let's just put it somewhere. Let's just put it somewhere and kind of see what happens. Suppose I put this charge Q right up here. I'm just going to put it as a little dot. It's my Q. It's a positive charge right now. Well, here's a positive charge, so that's going to push it away. I'll call that F plus. It's a vector. Here's my negative charge. It's going to push this way, F minus. It's a vector. And I want the total force to be 0. Well, since these are vectors, there's no way you can add up those two forces so that they are equal to the 0 force, right? Because think about it this way. Unless they're completely opposite directions, there's no way they can add up to 0. Imagine pulling on an object with two forces, and the only way you can get those two forces to add up to 0 is if they're in opposite directions. And these cannot be in opposite directions because they're off the axis. It doesn't matter if it's a negative charge, the same thing would happen. I would just change the direction of the forces. They're still not going to add up together, okay? If I put it down here, not going to happen. 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 So I have to be on this x-axis. If I'm calling this the x-axis, that's the only possible location. Okay, well, let's put it right here. Let's put our charge right there. So now I have a force from the positive charge, and I assume this is positive. It's going to push this way, F plus, and then I have a force from the negative charge. That's a negative and a positive charge. They attract, so that's going to push that way. They can't add up to 0. They're pushing in the same direction, right? If I change that to a negative sign, they're both pushing this way. So they can't add up in the middle. So it can't be there. Well, let's try over here. What if I'm right over here? Now the negative charge is going to pull it this way, F negative, and the positive charge is going to push it that way. So maybe that's possible. And let's just look over here. If I'm over here, the positive is going to push it this way, the negative is going to push this way. Okay, so maybe those two regions. But if I'm right here, then this is a 5 microcoulomb, that's negative 3 microcoulomb. So I could possibly find a place where those two forces are the same. Over here, it's not possible, right? Because it's always going to be closer to the positive charge, and the positive charge has a greater value, so it's always going to be a positive. The force pushing in that direction is going to be greater than the force attracting to the negative charge. So that can't happen. So it has to be over there. So now we know where it has to be. We can solve for that. So let's move this charge over here. I'll put it over here, and we'll call that my x. And I want to solve for the value of x. Okay, now we can start doing some physics here. Let's just write down an expression for the force. So I have F in the x direction. I only have to deal with x components now. So I can say F is F plus F minus. So I'm calling that the force from the positive charge, the force from the negative charge. Remember that F is equal to K Q1 Q2, well, Q1 Q over R squared, where that's the Coulomb constant. This is the product of the two charges, and that's the distance between them squared. And that's the scalar version of that. Okay. So in this case, my plus is going to be K. It's in the positive x direction, so I'm going to call it positive. It's going to be equal to K Q1 Q over this distance squared, which I'm going to call x squared. Then I have this force is going to be pulling this way, so it's going to be minus K Q2, I don't have to worry about that minus, I'm already taking that into account here. Q2Q over this distance squared. Well, what's that distance? Well, if this is x and that's s, this is x minus s. X minus s squared, and I want that to be equal to 0. Okay, so you can see that it doesn't look super nice, but we can deal with nice stuff. We can work with this. Okay, let me go ahead and write up here Q1 is 5 microcoulombs, Q2 is -3 microcoulombs, S is 0.25 meters, so I can erase some stuff. So I'm going to rewrite this equation. I'm going to do it a little bit so I can have some more room. That's what's nice about chalkboard. I can erase stuff. So here's the equation that I have. I have K Q1 Q over x squared minus K Q2 Q over x minus s squared is equal to 0. So now I can erase this. Let's add this to both sides of the equation. K Q1 Q over x squared equals K Q2 Q over x minus s quantity squared. And you'll see that I have some things that can cancel, right? I can divide both sides by K. I can divide both sides by Q. Yay. Now we have a little bit easier. Now I'm going to take the inverse of both sides. And that may not be the most logical thing to do, but it would work, right? If I take the inverse of this and the inverse of that, it's still equal. So I can write this as x squared over Q1 equals x minus s quantity squared over Q2. Now I'm going to multiply both sides by Q2, and if I do that, I get Q2, Q2, and they cancel. So now I just have x minus s squared over there, and then I have a number, Q1 over Q2 times x squared. Let's just multiply things out. Q2 over Q1, x squared, and if I multiply this out, I get x squared minus 2xs, right? So I get x times negative s times x, so there's 2 of them, and then plus s squared. I think I'm going to use a quadratic equation, but that's okay. So now I'm going to subtract this from both sides, and I get, let's write this as q over 2 q1 minus 1 x squared, because if I subtract that over here, minus 2xs plus s squared equals 0. Now, it looks bad, but it's not bad, right? That's just a number. That's just a number times x. That's just a number s squared. So let me get these values, and then we'll plug it into our quadratic equation. So this is going to be, I'm going to get my calculator. This is Q2 over Q1. Now, they're both in microcoulombs, but it doesn't matter, right? Because the units cancel. So I can just take this as 3 divided by 5 minus 1. And I can write that as a number. Okay, 3, enter 5 divided by 1 minus, and I get negative, so this is negative, can you see that? Yep, negative 0.4. Here I have negative 2 times s, and s was 0.25, so this is going to be, let's put that as x squared, negative 0.5x, and then this is s squared, which is 0.25 times 0.25, 0.25 squared. 0.6020625. Now I can use the quadratic equation. So this is A, this is B, and that's C. So let's plug that into the quadratic equation. So x is negative b plus or minus the square root of b squared minus 4ac all over 2a So I can put in I'm gonna put my numbers in, negative b, so I have b is negative 0.5, so it's gonna be 0.5 plus or minus two answers, plus or minus the square root of b squared, which is negative 0.5 squared, so it's just gonna be 0.5 squared minus 4 times a times c, so it's actually gonna be plus 4 times 0.4 times 0.025, all of that over 2a, which is going to be twice that, so negative 0.8. Okay, so let's do the plus first. I'm going to put it in my calculator. You can too. I just can't see it. Okay, so I got to do it right here. So 0.5, enter, and then I'm going to do this, 0.5 squared, and then I'm going to add 4.4 times, that's a 0.0. 0.02625 times plus square root plus negative 8 point divided by 0.8 divided by, and I get negative 1.36, which I said wouldn't work, right? Because we said it had to be positive. So let's do the other one, x. Let's just do the same thing with the minus right there. So it's I shouldn't have deleted it all. I'm mad. Okay, so 0.5, enter, 0.5 squared, 4.4 times 0.0625 times plus square root minus, oh no, yeah, minus, and then divide by negative 0.8, and I get 0.114. And that seems like a good answer, right? Because this is closer to the positive, wait, it's halfway, would be point, is it closer to the positive charge or the negative charge? It should be closer to the negative charge. Well, we can go back in and plug it in our equation and check. I think this is fine. I might have made a mistake because when you're working on the board, you tend to make tiny little mistakes, but still, it's an example of adding forces together, so I'm pretty happy.